Prior to the solar fendon process, olive meal wastewater is pretreated in a tank specifically designed for the coagulation and flocculation procedure. The aim of the pretreatment is to reduce the solid fraction of olive meal wastewater in order to improve the efficiency of the subsequent treatment by solar fendon process that was later on applied. The tank has a cone shape and a total capacity of 90 liters. The pretreatment is carried out using ferrous iron sulfate heptahydrate as a coagulant and an anionic polyelectrolyte called Flocan 23 as a flocculant. The flocks generated by the coagulation and flocculation process precipitate at the bottom of the tank, while the remaining liquid is transported to the reservoir tank of the solar pilot unit. The pilot-scale photocatalytic experiments are carried out in a solar compound parabolic collector pilot plant comprising 6 borosilicate tubes mounted on a fixed platform tilted at the local latitude. The plant is operated in a batch mode. The surface is constructed of resistant and highly reflecting polished aluminium. Olive meal wastewater flows directly from one tube to the other and finally to a reservoir tank. Mixing is accomplished by means of a closed circuit through the irradiated part of the reactor and the reservoir tank by the use of a centrifugal pump. The overall volume capacity of the reactor is 100 liters, while the total irradiated volume, which is equal to the tube's volume, is approximately 22 liters. The operation system of the plant consists of the reservoir tank, the centrifugal pump, the flow meter, the air diffuser, and the UV meter for the continuous measurement of the solar UV radiation during the experiments. Also, there are 3 reagent tanks along with their dosing pumps, which can automatically dose the fendon reagent directly to the storage tank. The 3 reagents that are necessary for the solar fendon process are the ferrous sulfate solution, hydrogen peroxide, and sulfuric acid for the pH adjustment. The control panel of the plant is directly connected to a PC for the online data acquisition. During the loading of the reactor with the chemicals, the collectors are covered to avoid any photoreaction. At the beginning, the reactor is filled with the pre-treated olive meal wastewater. Then, the pH is adjusted with sulfuric acid and the appropriate volume of ferrous iron solution is added. Finally, a predetermined dose of hydrogen peroxide is added and the collectors are uncovered. Samples are taken at specific time intervals from the sampling point of the pilot unit and are further analyzed. The chemical oxygen demand and the dissolved organic carbon are monitored at each sample, while the presence of hydrogen peroxide in the treated samples is monitored using specific test sticks. Also, toxicity measurements are carried out in samples taken at various times during the photocatalytic treatment using Daphnia magna and 3 plant species. Solar fendon oxidation combined with coagulation and flocculation pretreatment constitutes a potential solution for the purification of olive meal wastewater, resulting in considerable organic load removal. The polyphenolic fraction, which is responsible for the biorecalcitrant and toxic properties of olive meal wastewater, can be eliminated by the chemical oxidation process. Interestingly, the solar oxidation process seems to be capable of achieving a reduction of the olive meal wastewater final toxicity, reinforcing thus the concept of sustainable wastewater use.